So let's go back into the development area and let's just talk about models and what models are in DBT. So models are essentially snippets of SQL code that help shape your data into a format that ultimately will be ready for reporting or analytics. Models are SQL files and they live in the models folder in the DBT project directory. Simple as that. And each model that you create has a one-to-one relationship with a table or a view in the data warehouse, in our case, Snowflake itself. So in your SQL scripts that make up your models, you write the SQL, you apply any business logic, standardization or transformations. Don't forget DBT is the T within ETL or ELT. But DBT importantly will handle any DDL or DML for you underneath the covers. So it will create the tables or views in terms of the output of your SQL that you provide. And we'll see that shortly and it'll become more clear as a concept. So now let's look into building our first model in DBT. And for that, I've switched back to Snowflake. I've went back to the script that we actually ran in the previous part of this video. So if you haven't seen that, I'll put a link up in the pop-up banner on this video so you can go back and follow along and get the SQL code. I'll also drop a link in the notes in the video description beneath this video so you can go to the DBT training and find what that is. And within those training modules, once you sign in, I'll give you the direct link to the actual lesson that this SQL is based upon. You can simply copy and paste the SQL as I've done here. I've just ran this and just reloaded the data into our environment. So if I refresh our objects, you can see we have our new database we've created with the various schemas and tables within them. Now I'm going to open a new query window and get the next part of SQL from the DBT lesson that we're working through. But here we've got a CTE pulling together using some of the data that we've just created in the previous step. And you can see that we're selecting some data from customers and the orders table. And then we're going to do some aggregation based upon the customer ID from the orders table. Finally, we'll use the customers CTE with the customer orders we've just created, join them together and provide a final result set. So of course we can run this code in Snowflake, which I'm doing now, and you can see the records are returned. And because this is simply SQL, I can copy this and go into DBT. Now, as I mentioned earlier, all of our models live in this directory here, and you can see there's this example folder with a couple of example models already available in there. And so we're going to create our SQL code right in this models directory here. And so to do that, I'm just going to check out the branch, call it development, and now you can see that we're working in the development branch in our development environment, and we can merge any changes back to master again, something that we covered in the previous video. And again, if you missed it, make sure you check that out. So if I go down to the models folder and I click the three dots here, I can click new file, and I'm just going to call this dim customers.sql and click create. I'm just going to paste our SQL directly into there. Okay, and now we've got the SQL pasted in here. We can click query results, and it tells you can click command and enter to preview the results. And that query in DBT then is executed on Snowflake and return the results in exactly the same way as if we were to execute this particular query directly on Snowflake. And so now we know the SQL compiles and runs and returns the records as we need them. Let's build that into our data warehouse then. So firstly, make sure we've got a valid SQL file, name of the table, .sql, and let's make sure that's saved as well. Next, we can come down to the command line down the bottom, and we're going to run a DBT command called dbt run. I'm going to execute that. This then allows DBT to look at all of the models that are part of your project. In this case, you can see there was 3 queued, and now we've got 3 have passed because we've got the 2 sample models in there as well as our dim customers. DBT works out what order the models need to run in as well based upon any dependencies that we've set and references, which we'll touch upon shortly. Then you can also expand the details for each of the models. And if we click details here, we can actually see the SQL that's been generated. You can see it's actually creating a replace in the view called dim customers. And then there's our CTE. And then there's the code that we specified directly in DBT as part of our dim customers. You can see that it opens a connection to Snowflake and executes the code within Snowflake. So now if we go back into Snowflake and we refresh our database objects and we go to our PCDBT BDB database, you can see it's created the default schema, my first initial and surname. In here then, we've got some objects I created earlier and also the dim customers view that we just created before from within DBT as part of running the model itself. And of course this is just a normal view, so we can open a new worksheet and go down to the view here. We can double click it to get the fully qualified object name into the window, and we can just run select star from there, and you can see we get the same result set as our previous query. But let's say you don't want this as a view, you want it materialized as a table. So let me show you how you do that in DBT. We go back into DBT, and we scroll to the top of our dim customers.sql, and we're going to create what is called a config block. And we can see we've got a configuration block, and we're telling DBT that it's going to be materialized as a table. We're going to click Control and S, or Command and S, depending on if you're using Windows or Mac. And then we're going to run DBT run again. And we're going to go down into the details. I'm going to say, and we can see now that DBT has created this as a transient table within Snowflake rather than a view. Let's just confirm this within Snowflake itself. So if we just refresh our database objects again, now we can see we've got a dim customers table, and we can also see it's cleaned up the original dim customers view. So now if we execute the same piece of code again, we're querying from the table rather than the view. So it's quite neat that DBT understands when you rerun a model what's changed, works out the deltas, and it can also clean up what was there previously. It's also worth pointing out what happens if you don't want to run all the models every time. Well, you can use this switch here, followed by the name of the model, so dim customers. If we run that, we can see there's only one model queued, which is now passed, and then we look at dim customers and we can see it's the only model that has run. So that's really handy. If you've got lots of different models and you've just made a change to one of them, you can just specify to run a subset of models or just one by itself. So at this stage, we've built our dim customers model. We've looked at how we can use a configuration block to tell DBT if we want it materialized or as a view. So everything works great. However, now we want to modularize our project. So what does that actually mean? Well, in this case, what we're going to do, we're going to split this up and modularize the whole approach to make it more flexible and more reusable, as well as part of a wider enterprise class project. So you can see here we go to the customers table as well as the orders table. What we're going to do, we're going to start to break this code down following DBT's best practices and create two staging tables, one for orders, one for customers. They're going to feed into our dim customers table, and that's what we mean when we talk about modularity. By modularizing the approach and breaking all of the SQL down into its component steps, we get a more flexible project, and it kind of promotes reuse of code objects as well. So firstly, we've got one model at the moment, dim customers. We're now going to break this into 3 models. So we're going to have this bit we're going to take out and make it as stage customers. This bit we're going to take out and put it into stage orders. And then finally, we're going to leave the final query that brings everything together as the dim customers model as well. So the first thing we're going to do is create our stage customers. Don't worry about these other folders I've got here on the left at the moment. We'll come to how to reorganize your project either later in this video or in a subsequent video around DBT. So I'm going to click the 3 ellipses here. I'm going to click new file. I'm going to type in stage customers.sql and click create. I'm going to go here, I'm going to copy this code out, and I'm going to paste it straight into here. And then we're going to select start from customers to complete our query. So let's just run this query, and here's our result set for our stage customer model. Next up, we're going to go back to our dim customer SQL. We're going to remove that query from our dim customers because we've already broken it out into stage customer. Next, we're going to do exactly the same again, but this time it's going to be stage orders.sql, and we're just going to do exactly the same again. This time I'm just going to remove it from there completely and paste it in here, and again just complete our query like so, and make sure that the query compiles and I get the results back as expected within DBT, which I don't because I needed to have the with statement at the top, which I missed. And there we go, there's our orders stage. Okay, so now if we go back to our dim customers, you can see our query looks like this. So we need now to reference our staging models, the CTs that exist in there that we've taken out from within dim customers. So to do that, we can type with customers as select star from. Now, how do we reference the stage model? Well, there's a function in DBT which is really important and very commonly used for basically create these dependencies between different models. It's called the ref function, and you've got two curly brackets either side, and in the ref function you will then pass in the actual name of the model that you want to reference and refer to as customers. And we'll do exactly the same again for orders. And if we look at the rest of our query, we're referencing orders here, which relates back to here and right the way through to our staging orders, and here we're using customers, which relates back to here. So this query looks all good. So now we're going to hit save, and we're going to look at the compiled SQL. If we compile the code, this will refresh, and you can see now that the compiled SQL is referencing our staging tables based upon how we've structured our models within this project. So if anything changes in stage customer over here, we don't need to worry about changing anything within this main query as well. If we go over to lineage, and so now I've just spotted I don't need that extra width in there, that can go. Okay, so now I'm going to issue a dbt run command. Now dbt's worked out that stage customer and stage orders needs to be run before we can run dim customers. Again, if we look at the details, we can see it's created as a default as a view. There's our CT within it for the customers one. Same for the orders. Another view, staging orders. And then our dim customers are getting created as a transient table, referencing those stage tables. Heading back into Snowflake and refreshing our database objects again, we can then see our stage customer view, our stage orders view, and our dim customers table, as we would expect, which are all created in Snowflake by DBT. Back into DBT, if I click View Docs, this is where the documentation is generated by DBT. We haven't actually told DBT to create the documentation yet for our particular project. That's something that we need to do. So we can come down to the command line and type in dbt docs generate. Execute that command. That will look at a project, look at all of our models within that, generate the documentation for us. It tells us your documentations are ready to view. If we click this, You can see here then we've got our project, we've got our dim customers. It tells us what columns and data type it makes up dim customers. We can also look at what it depends on. There's our stage customer and stage orders. It's all interactive as well, so you can actually click through, have a look at some of those stage tables. But if you look down here on the right hand side, you can click view lineage graph. If we click that, it's context sensitive, so because we're in stage customer at the moment, it shows us the direction of travel for that. But if we click dim customers, we can then see our lineage graph, and we can also amend what that looks like on the screen. But because we're using the modularity approach and the reference functions in DBT, it allows it to create a DAG in the background which works out what those dependencies are, so you don't need to, and everything gets loaded in order. Plus you can reuse the staging customer and staging orders, staging tables or models within DBT for other target tables as well. So it gives you that ability to reuse existing models within DBT. The benefit being, of course, if you needed to change any logic in any of these, that will flow through to any dependent target tables that rely on those stage tables as well. So this video took you to the next stage. It's introduced the concept of modularity. We've created our first model. We've worked out how we can use the SQL, use the reference function as part of that. We've also had a tour of the IDE and what different logic is in there. The next video I'm going to do is going to be a much more comprehensive session around building a model, using some exchange rate data that we're going to get from Snowflake's data marketplace. And I think that you'll find that really useful. We'll also structure and restructure our DBT models as well as part of that particular project, so you can get a sense then of what it might start to look like in an enterprise class environment. So with that, keep watching, keep subscribing, and I'll catch you in the next video.